Okay, so here we are. Good night, everyone. I'm happy to be back here. It's Code Number session number 18. This is the last experiment we've made. Yesterday, in fact. I'm quite happy with this one, and I thought it might be interesting to continue to explore movement directly inside the shape. Maybe keeping the same shape right now, or another one. I don't really know. Maybe another one, I think. So yeah, a quick chat about this experiment. We've seen yesterday that we have quite some bugs inside these scenes. I'm a bit late. At first, I want to say that I'm a bit late for this tonight live coding session, because I had some weird error on the project. Unity seems to have messed up some meta file due to git submit. So I've lost the NDI capability, I've lost the FFmpeg capability, which has basics for me to show you everything, especially to get the bottom right picture, and also to save all my iteration inside one little file. It seems we received the Unity NDI with a bit of latency also. So yeah, I had some things to relaunch and to retext in order to have everything working perfectly. Let me check this. It's connecting. Let me check. So I want to get this one. The NDI output from Unity seems to be more stable on the one I'm getting from it seems more stable than the one I'm getting directly on OBS Studio. So okay, that's I was thinking about maybe a problem on the NDI plugin, but it's not, so I'm happy with that. Okay. What I want to say also as an introduction is I've also some bugs inside this little scene here. The first one is, I think, an error on the rotation matrix, but as you can see, it seems also to have an error when we're resetting the position. So we have this kind of glitches here, and I really don't like that. I don't know why it's popping everywhere, and I'm not sure about what's producing that, so I want to explore that. And yeah, I know I have a problem also on my rotation matrix, which is compute on the shader side, because I've tried on another experiment, the one I want to make for tonight, and it was really messy when I want to rotate something on two axes, so on the X and on the Z, for example. So something like rotating like on this axis, for example, so rotate on Z, rotate on X. My shape seems to be skewed, so it's not I have various problems, but I think I will try to retake everything the last week of November, which is next week. I think I will take some, maybe the week. I think maybe I'm thinking about that. I'm thinking about taking the next week to stop the iteration. So I will maybe make a last body iteration next Sunday, and then taking the next week to continue the stream dedicated to cleaning all the files, finding some bugs in every scenes, in every shader, simplifying every controller, erase all duplicate controller, etc., etc. So it might be interesting in order to get a clean project, because I think I would be able to continue this project later, after this November session. So yeah, let's go for the idea of tonight. I've already prepared the scenes, so I'm not late on this one. Let me just clean up a little bit everything. So okay. So yes, I've prepared the scene for 11:18. So this is the scene. If it's want to load, please. Okay. So I've prepared the controller, and I've put some little elements inside of it. I've prepared a shader, a new compute shader, etc., etc. And here it is. And you will see it's a bit dark tonight. So this is the idea. And you could say, whoa, my, why that? Let's put that. Okay, let's try to open the compute shader for preparing everything. So compute shader, and this is this one. Okay, so yeah, let's put some quick size inside of it, just to have some little guy here. Okay, so what's the idea behind this shape? Let's say 150. So basically I'm taking the scene from yesterday, and I only change the elements, the 3D models. So as you can see here, it's basically let's light the scene. It's a shape made of skull head, so it's a little bit dark, but I would change the behavior completely. So the idea, I've talked about that earlier this day with a friend of mine, and I was thinking about exploring some kind of, some kind of blending shapes. So the main idea is having this little skull man here, and having something going from a dark place, a dark theme to a more brighter one. And to do that, I want to take each skull, and then by using, I think we will also use the elastic curve, but we will use the time, and the first animation would be having the skull just changing its shapes to go from a skull head to pop a pure sphere, and also the skull will go from a textured skull to a lighted sphere. So we will add some light into it, some emission, so pop, and this light will go up and fly above the shape. So I think we might also talk about some references which can be useful for this little experiment. And I think one useful and beautiful reference can be this marvelous movie from Pixar and Disney, which is Coco. And Coco has a universe about death, and its universe is just amazing and full of poetry and full of emotion and full of everything. So yeah, maybe we can just, I want to go when, so this part is not the, okay, and yeah, that's when it's, so yeah, it's each flower is luminescent, and all the deaths are really happy, and it's joyful, and the universe is really interesting. So that might be one of our references in terms of emotion. Okay, so let's go back to our little guy. So in fact, we don't need this part now. Okay, so we could simply say, okay, by to this, first of all, so this part in the loop. Let me just go back, rewind a little bit. So yeah, this was basically the copy of the compute shader we made yesterday. Okay, and this compute shader, basically for each instance we compute some time with some randomness, etc, 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 and the main, yeah, we could say that the main idea was using this time with a max time. So the time is a little bit offsetted, and we have a max time different for each one, so each element are quite different, and we compute the number loop of the time. So we're going, for example, from 0 to 5. Okay, 1 2 3 4 5, 1 2 3 4 5, 1 2 3 4 5, and we count the number of loops we made. So 0 1 2 3 4 5, and with this loop we can define if the animation was a growth or a fall, and we simply used the modulo in order to find the even number of the loop. So if it's an even number, then it will fall. If not, it will grow. So 0 1 2 3 4, it will be fall, growth, fall, growth, fall, growth, etc, etc, etc. So one of the glitch might be come from that part. So as yesterday, let's first start by setting everything to the same time. I've also commented everything here. So why I've commented this just to disable the fall. The fall will be replaced with I think it would be again a curl noise going up. That might be interesting. Adding some elements, so it will not be physics anymore. And this is the growth, and also we would disable it later, so it would not be a problem. Okay, so okay, growth, fix, okay, growth, fix. Okay, as you can see, we can basically see one of the, I think we can basically see the bugs we had. The bug seems to be happening. So here we're defining the position, the rotation, so let's disable these parts, of course. We don't need that. So we redefine the position, we redefine the growth, and we redefine data.y, which is not necessary right now. And let's check if we still have our return glitch. Okay, as you can see, we still have a glitch. Tack, tack, tack. Okay, so it seems that the glitch comes from this. What happens if I say something like then the size would be simply multiplied by 0? Do we see some glitch inside of this? Okay, and if we said something like maybe we need to change some of the parts that will not be bind after that. So maybe if I don't change the size, so let's check that. There is an error. So scale, oh yeah, because scale is that. Scale is defined here, so let's define the scale here. Okay. So pop, pop. Okay. So it looked like the problem might come from this. So basically, when we are changing the loop, we have already bind some time, because we're changing the loop before, I think. Do we want to change the loop for the last element? So yeah, as you can see, it's quite different. Okay, so now I know where the problem comes from. If I want to fix that, I need to fix the scale. the scale is moving. Okay. Something that might be useful is simply saving the time inside one of the components. Because this continue during, so it's not really perfect. Or it might come from something else. Let's try. Maybe it comes from the easing. Okay. So not that. Okay. What could we do in order to try to simplify that? So if we are changing the loop, we could say the norm time is also equal to 0, which could be a third time of the mode time, but I think we're using the norm time, so it's not a problem. Then 0. And let's define the time after that. Shit. Oh, what a fucking shame this. Let me relaunch the stream on Instagram. Let's say float mod time. So mod would be equal to 0 float norm time is equal to 0, then if we are on the same loop, and we could compute everything. Okay, so I need to take that, go back to my parameter inside PS Studio. Okay, and let's restart the stream. Okay, back in Unity. and on Instagram also. So I was saying something like that. So yeah, I was trying to add something like that just to check if it's working. Okay. For me, it seems to be working. Some kind of can I say that? It's some kind of a tweak. Let's say something like that. Okay. So now I can simply bind the scale every time and check if we are getting the right scale. Okay, we still have this little tweak, and I think it's because we're going to 0. So we might say something like that, 1 because it's the end of the animation. So we're changing the loop. So let's define this as the end of the animation. And now we have fixed everything. So you know, no glitch. We're only seeing the animation when it's going back. Okay. So that might be our way. Okay. So now that we have that, we would need value thing. Let's try to write it down a little bit. So what do we want? Let me take my quick my pen. Too tired to speak English. Okay. So we have different things. First of all, we will have some kind of apparition. That might be some growth. That might be some. I think the growth we have explored that too much. So maybe we will simply have some fading. So at time 0, from a value to max time, so it would be n, for example. Okay. This would be some kind of fade. Then we would have from 0 to m, our second max time, would have something like the element with pop, changing its size. So size and light, JHT, and so loop 0, loop 1, loop 2. Okay, and when we go to loop 2, so the third loop, 0, 1, 2, the displacement. Okay, so the curl plus wind as our element, just going up and down, and Instagram has crashed again. Okay, let me finish my explanation. And also we could say something like a scale down, because it would be some light sphere, so let's use a scale down. Okay, so before going to so 0 n m o. Okay, so let me just go back here and try to set some and just stop the stream because the stream has finished. So okay. Maybe we can simply make some quick video. Okay, back on Twitch. So yeah, I was thinking about three basic timing. The first one would have this. Okay, so the first one is okay. So first one would be only playing with the fade. The second one would be changing the size and the light, and the third one would have some curl and wind, etc, etc. So let's try to work on that. First of all, let's work on the fade. So in order to get everything we want, I would simply load our shader here. We are using this, so 0 alpha test. So I will need to put some data directly into our little guy here. So we know that first I will not use any of the curve right now. I will simply try to work by my own. Okay, so you know what, let's simply comment everything and let's modify a little bit. Okay, so by saying that, basically I will start my first loop at 0. So this is the main element. So I could say something like that. I would write everything here, that might be better. So if a loop, which is the actual loop, okay, is equal to 0, this would be fade scale. Else, if a loop is equal to 1, then this would be the shape blending plus lights glowing and else if a loop will be equal to 2, then it would be, and let me just correct my typo here, and it would be some wind up plus curl plus size down. Okay, so fade curl is quite easy in fact. Let's simply say that we can put some data. So what kind of data do we have available here? So let's open some folder, some file here on the GPU mesh controller 18. So remember, we have some slot for the data, which is this little vector here. So this is a random index, sure, so this is the index, this is 0, this is a value. So y would be the time per instance, z could be the loop in fact, and w could be the random value we bind at first. Okay, so do we want to compute the time? I think we would need to get the time per instance. That might be a good idea. We could also store this element. So the fade basically can be stored here. So we will use that. Okay. So at first, just be sure that the fade is equal to 1. So we could have a pure opaque element. Okay, let's go back here. Oh, and we don't need this part also because we didn't use this anymore. Okay, wait until it's compiled. So yeah, so while it's compiling, I will, okay, it's ready. So if the fade is really set to 1, I could simply change this by saying to my material here that I want my shape to appear. Okay. And I need to change that because we store here in the data.color. So here we use the norm time, which is not the proper value. So let's use this little guy here. Okay. So now we have our little man here. Let's continue our compute shader, fade scale and plus plus position at vertex. Okay, so because we need to put the position at the vertex in order to have the movement. Remember this part. Okay. So let's say float 3. We have this position here. So float 3, the position is basically the element. So the fade would be taking this. Okay. Property.color.a would be not equal. Let's go back in the binding here. I will put this into a value. So this would be our alpha value. Okay. And the alpha, which is here, let's say it will be a float alpha which will be equal to 1. So now the alpha could be equal to the norm time. Okay, so 0 to 1, not a problem, not at all. Then position, of course, could be simply this little guy here, so we will take the position inside the buffer. We've already made this a lot during this stream. So this could be our first part if I hadn't made any mistake inside my script, which I made because the norm timed has some capitalized T. So now I could see some fade in, fade out, if I'm correct. Oh yeah, and the alpha tested need to be to 1. And I've made a mistake, of course. I've said something like that. My element is not that. It's not the actual loop. In fact, we need to compute the modulo of this loop. Okay, so as we have this modulo here, which is equal to this, okay, we need to compute that. Also, it's int. I think the modulo would be better. And this would be the floor value, for example. Okay. So yeah, because here I'm only taking the first loop, and if I say loop equal actual loop is equal to 0, it would be just true for one moment, which is the first loop, because the loop will keep incrementing 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, etc., etc. So a better idea might be to say mod loop and then compute the modulo of this loop, but instead of taking the time, we will taking the a loop, and we will try to find a modulo of 3 by taking an incremental value going from 0, 1, 2, 3, 4, 5, etc., etc. into a modulo. I will retrieve a value going from 0, 1 to 0, 1 to 0, 1 to 0, 1 to, because the modulo is giving us the rest of the division operation. So now I can replace the a loop here by the mod loop. So of course, if mod loop equal to 0, we will be in our first step of our animation. It will be 0, 1, 2, 0, 1, 2, 0, 1, 2. It's a pattern. It's our time pattern. So it's a way to sequencing animation. Okay. We've seen that. 1, 2, and 3. 1, 2, 3. So the main problem is it's quite strange the way it's changing here. Let's say a bigger max time. I remember why I said it a float, because the time is okay. It's in second. So now it's okay. Now we have our fade. Stop. Fade, stop, and go back. So of course, as we're playing with the alpha, we could also change this by saying if we are at the end of our animation, we could simply set the alpha would be equal to 1 minus norm time, so it would be a way to redefining the alpha to 0. So stop, then going back and going up and going back, etc, etc. So again, I'm using the same fade, which use some kind of discard and basically a threshold matrix. It's a way to have some kind of fade without using any transparent shader, and I kind of like this fade. We could change the threshold matrix, but okay. So this is the first step. We have the fade. Then we could change the size and the lights and the curl and the wind. So let's focus on the wind, the curl, and the scale. So I've said that here we can simply put the loop. I think we don't need the loop inside this value, but I think we will put the modulo loop, so the mod loop. Okay, so this could be useful. Okay, that's also so as I said, it's here. This would be in data.z the mod loop. Okay, perfect. And this would be our time, not a problem at all. So okay, so I would try to take this little win. So remember, we've used the curl noise a lot, so let's try something like that. Let's say float 3 curled would be something like that. Some like I think it's curl. So let's go back to the util function here and taking the noise, going back here. So it's a curl noise and it's taking our float piece. So it was something like taking the position multiplied by a curl scale plus our time multiplied by a curl speed. Let's not call this a curl scale but a curl ink, and this would be multiplied by a curl scale. So this is our 3 value. First one would be simply the multiplier of the position in order to get a nice curly element. The second one would be some kind of let's say the speed of the curl noise, which is defined by the time because it's the time which offset the position. So it's a curl speed, and this could be really slow, something like 0.1 for example. And then the curl scale is basically the size of this position incrementer. So this vector, it's the length of this vector, so we could say something like 0.25 or so. Then if we want to apply this, it would be something like position, and we would say position plus equal our curl. Okay, so let's rename this a curl. So this is the position. So we could try this one. We are already binding everything, so let's try that. Okay, made a mistake somewhere. Well, this is a oh yeah, I forgot to declare the type of every little value here, which are some float value. Which seems to be okay to me. Oh, and remember we're on Twitch, so I can simply try to get a little bit of more. I could basically say that I want my error to be on this side. Okay. It's appearing. It will be Why don't we see any other modification we've made? It was working here, so why not? We have simply bind this, but okay, then it would fix. Okay, then okay. So this could be working. It's a float 3, yet it's a float 3. So we are taking the actual position. Okay. And the curl, of course. So the curl needs to be really small, I think, on the curl scale. It's strange. Okay, and now we have our curl. Okay. So we could also add a wind. So the wind, it's a wind up, of course. So this is basically a simple float 3 here, which is 0, 1, 0. Or I can put everything to the same place here. Okay. And I could set this plus have a wind, which could be something like that. And we will move a little bit up for each time. And fix and wind. So as you could see, it's quite too much. So we could also say something like that. We could simply take this 2 little vector and then multiply by the curl scale. And it's okay. Not perfect, and I think the scale here are a little bit too much, but yeah, something like that is really more interesting. So we could also try to change the scale, of course, because now we have this. So we could say that the scale would be something like 1 minus the norm time. Okay, so it will be multiplied by this just to scale down our shapes. Okay, so the first part and the second the first part and the third part are quite good. Some things I'm kind of interested is knowing why, if we put this mode loop, everything was different, because I didn't think we've used in the data.c somewhere. So let's check in data.c. So in the data.z does not exist here, and I don't think it would be exist also in our shader here. We're only putting this here, so not a problem at all. So I'm quite amazed by the fact that it would be so. Yeah, if I put the mode, as you can see, it's basically totally mistaken by everything. Data.x, data.w. Do we have anywhere where we put the data.c, for example? Oh yeah, of course. Of course, I'm such a fool. Yeah, this is the index, the time per instance, and the z was simply the loop. It's the loop and not the mode loop. So this is basically the loop, so I don't need to rewrite this. Okay. So you know what? Let's try at first create some kind of float sec time. Okay, this could be 1 minus norm time, because I will use this here. Okay, and here, and this would make the same here, sec time, but this is this value. Okay, and because we are here, we will say something like that: sec time is equal to the norm time. Okay, so basically what I want to make with this little value is creating some kind of sequence time, and at first it would be the norm time, of course, but in each sequences it could be different. It could be the norm time, the inverse of the norm time, and also for each sequences we will have a custom curve on it, and I will bind this value to our data which are streamed to the shader. So here we use the sec time, and here the sec time we redefine it by saying that it's the normal value. Okay, so this could be correct. Okay, fade in, stop, and going up and stop. Okay, so now we can bind, as I said, to this our sec time. Okay, I think we have everything we need for this part. So let me just take this. Of course we don't have any curve on the animation right now, but this part is okay and this part is okay. So I need now to create some light and change the size. So the size will be directly changing in the vertex shader, so I would need this element. Okay, let's try to go directly in our vertex shader. Let's clean this a little bit so I could get rid of this part. I think this part we could get rid of so. Okay, so this is the data we will need. Right now I will keep all the other value. I will clean up this another time. Okay, so o.data. So remember, o.data, this is it. This is this part. So we have a random value. Okay, so this is x time per instance, loop, etc, etc. So I could say something like that: if loop modulo of 3 equal 1, and here we have some blend shape plus light. Okay, so this is the main idea. Let's continue our little view here. So if mod loop equal 1, well, yeah, this is the blending. So this is the norm time, so not a problem right now. So first of all, let's take a copy of the vertex. So we will name this norm vertex, which is equal to the normalize value of the vertex dot xyz, and of course this is on the v element. So the main idea is to take the vertices. So if I remember correctly everything, right now the vertices are in the model space, which means they are the description of the vertices of the vector going from the pivot point to the vertex. So if I normalize this value and I multiply by something else, I could simply get a pure spheric shape. Okay, so for example, if I say something like v dot vertex dot xyz would be equal to this new norm vertex, I could get some kind of sphere. So this would be some spheres. Unexpected token loop. Oh, of course I've made another token loop because I haven't declared everything. So the loop in is o.data.z. So okay, and does it work? Okay, it seems to be working. As you can see, let's go back a little bit. The sphere is really too big, but we haven't seen everything. Let's retry this by simply saying that This would be this multiplied by 0.25, for example. Does it work or does it doesn't work? Okay, so now this is our sphere, and we are going back. So those we have the same thing when we are in the second time of our repetition. It doesn't seem to be this. So why? We still have this, but but in the data we have this. So why? This is the mod loop, which is the modulo of the loop, but we bind the loop Let's try to check a little bit the number of times it's changing. The first time it's okay. Going up. So we clearly have the 0, 1, 2. But the second time it's not. So let's check the third. No, it's only happening once. Why? This is why I wanted to put some value directly into it. So maybe we can get rid of this random per instance. The index, we need it. So where do we put our data? Let's say this would be our mod loop. Okay, and this would be data.w. Okay, so in data.w we would put our Did I take the proper value or not? So let's put this little guy here. So I will not use this. I would simply say random multiply by this. So I will not use this as a random per instance. At first we will bind something like that. So this would be our mod loop. Okay. So now I can take the data.w, which could be, I think, 0, 1, 2, 0, 1, 2, 0, 1, 2. Incorrect number of arguments were random per loop, but yes, I didn't use this. Okay, so 1, 2, 3, then again 1, 2, 3, and it's better because we don't need to recompute the mod loop per vertices, per vertex. So okay, so this is the main ID. Perfect. Okay, so we could also use some kind of, I would say something like 0, 1 for example. I think we will add more data to our structure, which is not the best, of course. I have a lot of data in the structure, so it's not really great, but let's do that. Okay, so now this is the vertex, and what I want to do, so let's say we multiply this by 0, 1, which is our scale. What I want to do now is simply creating a linear interpolation, okay, on the time from this v dot vertex dot xyz to this norm vertex. Okay, so this is the end of my blending shape, and I will simply taking o dot data dot y, which is the norm time, of course, because we've put it here. This is the second time, so it would be a good way. 1, 2, 3, and then it's okay, and now it's a ball, and after it's a ball it will go back. We could also say something like else if, and we need also to say that if data, so if our mod time is simply that, so we would simply let's say if it's strictly different to 0, so this would be better in terms of, so if it's not the first time, I would if it's not it would not the first sequence time, I will compute our little norm vertex, and because we will use it in the 2 other sequences, so if we are in the second sequence, this is where we have our animation, and if not, then v dot vertex will be equal to our little norm vertex. Okay, so let's go back to 25 here in terms of scale, just to be sure to be able to see everything. So appearing, blending, and going up, so it's okay. We could also, now we could focus, the size is good, we could focus on the light. So let's go back, let's take this part, in fact, let's take this part and let's go back to the fragment shader, and basically we will add some emission into it. Okay, so we would say something like that, lights. Okay, so now we are not taking the o.data, but the real name is now, because it's a in.data.w. okay, we will not modify the vertices. So if we are not in the first pass, then we will have some light. So in this we have the glowing starts, and here we are on the glowing. So this would be something like that. Let's say we would put something like float light on, I will call this that, so let's say 0, and then if we are on this part, then light on would be simply equal to in.data.y, which is our little time again. If we are on the other part, then we will be equal to 1, and I could simply say here, can add to the emission basically a new little element, which is float 3, and we would add to the emission a white light multiplied by this light on value. So this could be our light. So as you see, it's really not what we wanted. It seems the light is fading because of course we're changing the alpha, but here the light on value doesn't kick in. Why? Maybe it's because we have too many emission. I think it's okay. Not perfect, but okay. So let's try this. Okay. This is clearly not what I wanted. Why? Because we add that, so it was simply o.data.y, so it was not a problem. X time per instance and loop. Okay. And here o.data.y doesn't seem to affect anything. Maybe it's because if I put an emission of 0, 1, it's too big. Oh, as you can see, yeah, might be the problem. Let's say 25, so based on the time it's really so we would offset the time, I think. It's really speed. The time we get from 0 to 1, it's really a speed up. So we could say something like a smooth step, for example, of this. Okay, going from, I don't know, 0.25 to 1, so only on the last part. And this would be a way to whoa, it's really kicking really hard, but in the data it's basically our sec time, so of course I forgot that the sec time was inverted here. So at starts we'll start with 1, so it will be 1 minus no, not here. No, we're still in the correct element. So why do we have this? Why do we have this is a mystery for me right now. As you can see, it's really a mistake. It's really a mistake somewhere and I cannot see it. Let's try with a step, for example, if this basically go from behind this, some light on could be this. Not sure about this part, but let's check it. does this emission? It's really strange the way it's behaved. Look like something to 0 is so pop, and now you can see it. It's full lighted, so I can't say. Do we go? No, it's really somewhere else, because this could be basically sending. So if I say global emission, fuck. I could see something like that, in fact. So going this and this. So this is the main ID, okay? So why do we have a value which is basically not this? I'm not sure about that. Because if I put this in the data.y, okay, so this is correct, this is correct, and the other part is also correct. So why? Why does it happen here? Do we need to change this little guy A and say something more like that? For example, something like this. Oh, I'm really such a fool. It's also a mistake here. Okay. Time per instance, Z is a loop, and W is the mod loop. Okay? Remember, we've put in the mod loop. So why do I think that? No, it's simply that if data.w is different than 0, then we have that, and this is the same here because we are already in the mod loop, so I don't need to remake a modulo of that. So it's more something like that, in fact. So that's why it doesn't working. It's not a binding problem. The mistake was behind the desk and the chair. Okay. So it's kind of better. Not better, but it's kind of better. Okay, so now let's take this again. So float light on is equal to 0. If the mode of the time is different than 0, then here lighten would be equal to in dot, let's take only the fractional parts, if not glowing will be equal to 1, so lighten will be equal to 1. So now I can say O dot emission equal multiply dot 3 1 1 1 by lighten I'm not sure we would get something perfect, but let's take a hint, of course, to be sure. And it's clearly not working, because I think we've disabled everything, so if the emission is equal to 0 we would not have anything. We still have the same mistake. I'm clearly don't see any problem here. Seriously, I'm don't see anything. I don't see anything. Why do we have this popping value? I really don't know that. Does it come from the fact that I've had a hint here? I'm not sure, but what I really don't understand is clearly that we are going from 0 to 1 is like a snap. So pop, glowing, and then going back. So maybe it's not perfect. Maybe I will need to say something like a floor value of that. Of course, sec time would be equal to the norm time, so it's not a problem. Okay. Clearly not what we want, but let's try now to offset this a little bit just to check if, because the mistake is here, really. In the data the W, but in the data the W is passed here. You see this? It's clearly not working. I could say something like that. If it's clearly, if this is equal to 2, so 0, 1, 2, but the else seems to be the solution. So we are not passing to the 1. So we're going from this so something like that. So if it's equal to 1, or if it's equal to something, if it's equal to 1 or if it's equal to 2, for example. Yeah, I think that was the mistake. Maybe we don't need the discard on this one. So I think we have the basics system, the basic system for this one. Okay. Of course, we could say something like AO, which is AO. AO is I think we don't have an ambient occlusion for this one. So let's delete this ambient occlusion here. Okay. But we could also say let's keep this value for now. Okay, and we could get rid of the alpha, for example. Instead of this, we could say something like that. Because having the discard plus the light is not really beautiful. So discard, glowing, and pop. Okay. Okay, so this is the basic. We can try now to offset the time and see if we have any problem into this little experiment. As you can see, so maybe the size is really too big. Let's check if the ambient occlusion and if the post-process is making some, maybe the ambient occlusion are making a okay, so it's not a problem of the ambient occlusion. We might have a problem on another way for this lighting. So of course we could simply say that we want to reduce the size. We could also try different things. Okay, so this could be our size, not a problem. So we still have a problem here, so let's try. We could also say that the discard will only be computed if we are on the first sequence time, because we only need these parts here. So let's try that. Okay. As you can see, everything is changing, so let's take a new random here. So this is random 2, and we will use this in order to offset the time. Okay, so time module max time. Okay, seems correct to me. Okay, now it's better. So we could change some of these little elements. So for example, maybe we want to change this. For example, we can also say that the growth would be based, for the growth the elements would be it will not stop, it will growth and then became some kind of glowing shape. Okay, so we could reduce this. So let's say the max time is behind something like 2 and 2.5 seconds. Okay. Okay, we could add more elements. Let's say I think the skull, how many elements do we have in the skull, for example? For the 3D model, I think this one. How many? Ooh, a lot of vertices. So we could start by simply try to change a little bit this little skull just to have less elements. So we're going in the last hour, so we will need to add a lot of things into this. I think we would have various things. First of all, we would have to change the curve of this animation. So let me just relaunch it. Okay, so we have our skull here, so it's glowing and the elements are popping, so it's not a problem. But there's various thing I want to make. I need to simplify the mesh. Okay, so this is not a problem because right now it's a little bit laggy. Okay, we need to add some color to the lights, not a problem. We need to add some curve, so simplify the mesh on C4D side, adding some curve to the animation in order to have some fade in with some slowdown for the fade in, then some kind of popping element, so it might be interesting to for the lighting, maybe something like accelerating and then decelerating for the scale, for example. So why not? So this would be on computer shader side. Then the last part would be on the color, etc., etc., and this would be on the shader side. And also we will try to get rid of this little problem we have on the glowing. Okay, so this is my skull. Let's put a texture into it just to be sure that I don't break the UV while I'm simplifying this. So assets, model, skull, and this is the color. Okay, so this is basically the color. We also have some second UV here for the teeth, but we don't use them. Okay, so this is the skull and I need to simplify it, so let's try to polygon. Let's go to a polygon reduction, which is here. It seems to not breaking any UV, so we're going to 233 vertices to. Okay, so it seems to be good because here we have a number of 22,000 points, which is now reduced to less, so it would be reduced to 2,000. So yeah, going from 22,000 to 2,000, it's really a big deal. So maybe we can change a little bit, because 5,000 is kind of good, in fact. Okay, you know what, let's try with this one. Let's export this this OBJ to this one. Okay, and now we have less vertices, nearly. Yeah, we are now back to the 100 value. So something we could try is, we have a lot of data here, you know, the original pose, the acceleration, the velocity. We can try to get rid of some of one because we don't need them, of course, but we could also use some of them. So the velocity, we don't use this, but we could rename this little element. Do we use the oppose? I don't think so. And the original pose is a vec4, and yeah, we could put we can simply put some kind of random value directly into it. So let's try a random dot value here. W comp is used to store a random value for compute shader. It would give us more depth to our element. So this is the position. The acceleration, we don't use it, so not a problem. So this is a float 4, and we would take this. So this is a float for original position, and we could use this here. So this dot w in order to tweak our little value here. So let's focus on the compute shader. Okay. Also, I will disable the mixamo here just to say we will turn around. Another element which didn't move is this one. So we will not have this shaky camera because sometimes it's quite disturbing. So now it's better. Okay, so this is good. We have the random, we have everything we want. You know what? Each time we change here, we can change the value, but let's keep the same value for each one right now. So, okay, let's change sec time. Sec time would be something like a node quad of our sec time. Okay. Then here we can simply change the sec time in the mode loop, because the sec time is only used to have a smooth element. So we could simply say that if we want to have the sec time, to have the time which will be quicker, we can remap it using a smooth step, for example. And instead of going from 0 to 1, we will going to 0.25 to 1. So we will start at 0.25, so it might be a better solution. And we could have something like sec time could be something like a in cubic. So in cubic value, something like that. And then we could use an out quad here of the sec time again. Let's try that. So it's really speed, of course. So let's modify this by that. Okay, so now that we have that, we could something say a little bit, let's change, because I think the scale are a little bit too big. We could change also the ramp. Let's try this one. Okay, it's kind of better right now. So we were retaking everything. Let's try to see it with a more zoomed view. Again, we will need to change the mixamo rig because I don't want the camera to move. Yeah, it's better. Looks like the camera is still moving, I'm not sure. No, the camera is not moving. We still have these little elements here. So now we can focus on some other parts. Okay. Off and then going back. Okay, not a problem. So the sectime, the quad, everything is good. Could we remap? Do we remap everything? This little element, something like that, just to. Yeah, we could use a random, in fact. So you know, just to add some randomness to our little guy here. So now each has some kind of randomness into it, and maybe we can say something like that. Let's remap everything from something like the minimum would be 0.45, for example, plus random plus 25. So it would give us a random number between 0.35 to 65. So we would have another randomness value for dispersion. Okay. That's okay for me. So this part is okay. The curve, as I said, is okay. Now go back to this. This value is curved, and this value is curved also. So not a problem. If we are in some discard, so maybe we can say something like that. So now if we here, of course we would use okay. If not, it will be a float 3 of 0, 0, 0 for the normal. Let's say the same for metallic, let's say the same for roughness. And we will use a float 3 of 1 for the color. So the main idea is simply to say that yeah, but it would be a lap, because here everything will just simply change the color directly when we are in the transition phase. So it would not be better. So tuck 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 tuck. So as you can see, not good enough. Okay. But we could use something like that. We could simply say that we want to create a linear interpolation between RGB and this color, of course, using this. So okay, and we could say the same here and here. Okay. Okay, and here in the linear interpolation, okay, the third value would be lighten, which has an uncap little value here. O dot alpha, don't need that also. Unexpected token, where did we made an unexpected token? On metallic, yeah, this little guy here. Okay, as you can see now, it's kind of better, but we have some problem, which is the normal okay. So it would be something like that for the normal, for example. Okay, and for the metallic I could say it's purely metal and it's purely smooth. And now we have get rid of our little problem on the normal, so it's really better. It starts off looking to something. Okay, reduce a little bit the environment. Let's check our little guy here, but okay, so now we need to put some color into it. So we could use a ramp directly. Let's use this. So let's use a ramp light. We call it like this. And let's say this would be a sampler 2D. So float sampler 2D. Okay, and float for ramp would be equal to the text 2D of the ramp in dot UV main text. Okay, and now we could use the ramp dot RGB and the lighter multiplied by the ramp dot RGB. And text 2D to matching parameter text 2D UV in UV main text. It's basically, oh yeah, I declare this as a float, it's a sampler 2D. So now it might be okay. Okay, and let's use a little ramp, and I think we have it. And for the ramp, of course, I've made a little mistake. I need to create a UV coordinate, and I think we would get the random value directly from the inpose. So we've put this, so it will be something like that. So let's say float2 in dot oppose dot w and 0.5 because I want to sample the center of the ramp. And then we could finally bind our little ramp. Let's say, for example, this one. It's not the perfect one, but as you can see, maybe another one. This one, for example, this one is the same. Like that. Okay, so now let's reopen Photoshop and try to create a new ramp. So where is my Photoshop? Yeah, I need to log. Of course I need to log. I thought I've already logged, but of course I haven't logged. Okay, let's open our ramp. Not the 2D, but it's the first one, which is our ramp color. Let's open our ramp.psd and change this. Okay, maybe going from show you Coco, for example. So it was Coco. Nice, there is nice color into it, some kind of blue, but maybe we can put a little bit of blue inside of it, but not sure. It could be interesting, because if I've put too much orange, for example, so I will need some kind of color like that. I will also need here something more like some yellow, but really a cleared one. Okay, and we also add a little bit of red into it, something like that, and we would also add a little bit of blue into it. It's a little bit, yeah, kind of this one, you know, this blue here, this more like blue and purple. So let's go back to something like that and try to go to it without any proper gradient, just to be sure that we will have some nice blue. Okay, so I think this ramp might be good enough, something like that. Okay, so it would be 23. Okay, and go back here and let's use this little ramp. Okay, sometimes we have some little elements. Maybe the yellow needs to be a little bit too more into the white, you know, more like that, in fact, more clear if you want to have something more interesting. Yeah, The purple is kind of interesting. Okay, so something that might also be interesting in this one, I think. Let's try to add some more complexity into it. I'm not sure. I'm basically accelerating the wind animation, but I'm really not sure about this one. No, I think that something that might be really interesting is not the way the bubbles are popping and going up. It's not the idea. I think something that might be more interesting might be adding some variation directly into this vertex shader, because we have this oppose.data.w, which can be useful in order to get a random value. So we can use something like an linear interpolation using oppose.w, which is our little random value. And this could be something like 0, 1, 2, 0, 0, 5, which seems to be a good fit. So let's try that. So we're adding some kind of randomness directly into the bubble. So yeah, it's now more interesting. We could, I think, simplify more the mesh. So let's try by simplifying something like 90%. I think it would be enough. We still have we will have some kind of you can see some not irregularity, but some triangle. So let's say low 2, big low, big low. We will name it big low. Okay. So now in the model, where is it? This is my skull. We have low. It was this size, so let me just change it, because now we have big low, which need to be the same size. And in the controller, I will bind big low here, just to be able to have less elements. So now it's clearly better. Okay, and now that something might be interesting to get more depth into our little guy here, might be simply to add let's say some real bones into it. So let's try to find that in CG Trader. So let's I want to add some bones in order to have some different kind of elements, so it will not be only based on the skull. We had this, of course, we had this little guy here, so okay, but I think adding some bones into it might be more interesting. So going to something like bone, and I want something free, and I would have something like FBX. So let's wait until it finishes. I think I was a little bit too speedy in the research. So okay, bones. Let's wait until it's finally down. Okay, Now we need something free. And we want something like this. And maybe Obejioso. It looks like it's quite hard for him to find something. Why? It's always when I need something that it's not working. Okay. Let's try here. CG Trader. It's working now. Okay. Let's look into this one and into this one. This is an STL, so maybe we can look into this one also. Not sure, but what that? No. That's nothing. This one has a lot of polygon. Maybe some skull. I know this one, I've seen in the movie clip. I might be able to get some part of this one or on this one. There's a lot of 3D model which are free, so this is quite good. This not no, but this one is quite interesting. It has some texture. It doesn't seem to be PBR, but it's not a problem. And this one it has anything. So let's start with this one because I only need few part of it. I only want to put some bones, some random bones, you know. So I will simply create a bool just to check. Maybe the torso or something like that. Okay. We'll open it. So where were we? This is this one. Okay. Oh, it's rigged. Perfect, but I don't need the rig. And I don't need the skin, and here we are. Okay. So something that might be interesting is maybe getting the hand, for example. So the main idea is to get some part of it. So not all parts, but some part of it. So let's try. So let's duplicate this one just to be sure that we've saved this. This would be something like 2020, for example. Let's take some end. Okay, and something like that. So here we will have the hand. So let's try that. So let's find a bool. A without B. Oh, B subtract. B intersect, I think. This is B intersect. Okay, so this is the end that I want. Okay, perfect. And let's find another part we want. We still have this, so maybe we can have some foot. Something like that, something like that. Okay. Okay, it's a foot. And let's try to take a torso. And at last we would take, I think we would try to take the not too high on the torso. Okay. Okay, and then at last it would be interesting to have some simple bone. For example, one of the forearm, because the forearm is quite a beautiful bone, I think, because the forearm it has this little twist into it, so I really find it beautiful. Okay, so let's say we want this as a state object, so I don't want this part. This as a state object also. Okay, so I don't want this as a state object. Okay, let's say this as a state object, so this we can get rid of, and this we can get rid of. Okay, perfect. This is hand. This is foot. This is, I think this is torso. Yes, this is torso. Okay. No, this is not. Yeah, this is torso or not? Yes, this is the torso. Okay. And this is the forearm. Okay, we could now put everything into its proper place. So let's go back here, try this and say, hey, here we are, apply, reset PSR. Okay, torso is good. I think so. Let's try to see on the top. Yeah, the top is good. This is the forearm, so for the forearm we could say this would be something like here and something like here, maybe a little bit here. Apply, reset. Okay, the forearm is good. Then the foot, we need something here, a little bit on the top for the gravity center. Apply, reset PSR, and the hand would be here. Here, and then apply, reset. Okay, and now we could focus on each quick element. So let's say the forearm, how many points do we have in the forearm? Okay, we could try to simplify it a little bit. So let's use a polygon reducer. Yeah, it's better. Okay. Current state to object. Don't want that. Forearm. Okay. Perfect. Then the torso. Polygon reducer. It's really, how many elements do we have here? Oh yeah, too much. This is too much, but this is good. Current state to object. So this is our torso. The polygon reducer. Again, this is for the foot, which has too many elements, and now has quite enough. Maybe too much, so let's try to regain some detail. No, going back here. Current state to object. Foot. Okay. Polygon reducer, and how many elements do we have for the hand? 300, and now we have less, which is good, but maybe too much, so this is better. Okay, and current state to object. Okay, okay, so let's take the end, let's create a new document, let's put this here and export our OBJ. And let's save everything in our Codevember experiment in the assets model skull, and this would be and.obj. Okay, perfect. Then go back here, taking the foot, go back to the end title here, export, save obj, and this would be the foot.obj. Okay, go back in here, take the torso, export torso. Okay, delete, and go back here and take the forearm. I'm not sure about using all of them, but you know what, let's try. This is the forearm. Okay, perfect. Go back in Unity and now we could duplicate our little guy here. So let's say we want simply 100 of elements here. And let's duplicate, copy component, paste as new, and now instead of getting this, we would take the foot, for example, here, and we will need a duplicate, of course, of this. So this would be 82, sorry, 18.2, and this would go 18.2 here. So let's try this, and it's really too big. So let's try to find the proper size. So let's say 0.25, like our little head skull at first. So yeah, the foot is too big. 0.01. Look like good to me. In fact, we have some foot, which is quite mixed, in fact. Interesting. Okay, let's say that the foot is a size of this, for example, just to be able to have something quite different. Okay, let's now create a new one as new again, and now we will use something different. Let's say the forearm, for example, which I think would be again too much. One, two. So paste as new. Okay, so I set the forearm and this one. Okay, so again okay, so for the forearm, maybe we can go from this to this. Okay, so it gives more depth. Clearly it's a way to get more and more depth to our elements. So okay, again the forearm as a 001, so then would be the same 001. Apply the controller, and we need another shader, so it's the third one. Okay, perfect. So 25. Okay, and now a new one again. Oops, paste as value, it's not correct. I paste the value, which is not what I wanted. So 25, okay, paste as new, and the last one. So let's change the compute shader, and I say it would be the torso RST, which is here. So this is the torso 301, of course. Apply. Let's put the torso into it. Okay. So we can get less of this one. So let's say 25 of the torso. Let's say we get 5 torso into it. Torso is really dark. So now it's better. Okay. So for the end we can have 150. Again, it could be the same for the form. Might be interesting to have more. Let's say less, and let's say 75. Again this, but more head, and I think we have our little guy here. So here's our guy, made of bones, so a little bit dark, I know, but it's kind of interesting, and it's having all the elements we've wanted. So I think this defined the end of the stream, because this was the idea. I know this idea was a quite dark theme, but was something I wanted to explore also. So I hope you like this the stream of the day, in fact, and I want to say that it was quite interesting. We haven't found a lot of bugs into this one. We have some of them, especially on the lighting system. You might see that we have some dark area directly in the point, but it comes from the other shape, so it's not really a problem. So yeah, I hope you like this one, as I like this, and see you tomorrow for another run. So goodbye everyone, and have a good night. Ciao.